This is a lesson for Algebra 2, day 26, completing the square with complex numbers. We're going to do 3 examples here from the lecture today. These are the steps that you had from the previous lesson, and I'm going to add a new step 2, but all the other steps will still follow. So step 2 is now going to be if a is not equal to 1, then divide both sides by a. But you'll notice that all the other steps around it are all the same. So step 1 is the same, and then all the other steps after are the same. We're just adding a step 2 there. So I'll do number 1, number 2, and number 3. Those are the 3 that we went through the lecture today. Okay, I'm going to cover up number 2. We'll do number 2 on a separate slide. Number 1, first step is move all the constants to one side, so we add 46 to both sides. 4p squared minus 16p is equal to 50. Next step is a is equal to 4, so we have to divide the whole equation by 4, both sides of the equation by 4, and I'm just going to draw a line showing it's both sides. So 4p squared divided by 4 is going to be just p squared. Negative 16p divided by 4 is negative 4p. Leave a little space to complete the square, and then we got 50 over 4. Next thing I'm going to do is we're going to complete the square. When you find c, you get 4. So we add 4 to both sides. Next step, we're going to factor this perfect square trinomial. We know it's going to be p minus 2 squared, which is equal to, if we were to do 50 plus 4 as a side problem, you would get 66 over 4. Take the square root of both sides. Square roots cancel out with the square, leaving just p minus 2 is equal to the plus or minus square root of 66 over the square root of 4, which is just 2. Okay, square root of 4 is 2. Okay, continuing on, we're going to add 2 to both sides. And when I'm doing that, I'm going to actually move it up to the top here because we ran out of space here. It's going to be p is equal to 2 plus or minus the square root of 66 over 2. Now, as of this point, I've taught you to leave the answer like this. We can't really simplify it anymore. 66, the square root of 66, there is no perfect squares we could take out. However, the denominator of 2 is 1. We want to make sure that these two denominators are the same. So what you want to do is you want to change this 1 to be a 2. So it's really simple. Since it's a 1 here, we just multiply 2 with 2 here, and we get 4. So p is really equal to 4 plus or minus the square root of 66 all over 2. Okay, and that's your first example. The reason why we do that is that's the form when we work with a quadratic formula, which we'll work with in a few days here. That's the form that your answers will be in. Okay, number 2. Number 2, first thing you want to do is subtract 100 on both sides, and I'm actually going to do that first here, because we'll move all the constants to the right hand side. We got 6b squared minus 12b. I'll leave a little space is equal to negative 98. Okay. Next step, divide both sides by a, which is 6 here. We don't want that a there, so we divide everything by 6, so it's going to be b squared minus 2b, leave a little space to complete the square, is equal to negative 98 over 6, right? It's a fraction. Now we want to complete the square. We add c to both sides, which means we add 1 to both sides. When we add 1 here, we add 1 on the right side. So we can factor our perfect square trinomial. We got b minus 1 squared is equal to negative 92 over 6. Okay. Take the square root of both sides. Square cancels out with a square root. And we take the square root of the right side. So now what we have is b minus 1 is equal to the plus or minus square root of negative 92 over square root of 6. Now we want to add 1 to both sides. I'm going to move the next step all the way to the top left. I ran out of space here. So we got b is going to be equal to 1 plus or minus the square root of negative 92. Now the square root of negative 92, we have the negative sign, so there's going to be an I that's going to be brought out. And I know that 92 is 4 times 23, so I could take out a 2. So it's going to be plus or minus 2i rad 23 over rad 6. The next step, we don't like this radical 6 here, so we need to rationalize the denominator. Rationalize the denominator by multiplying by rad 6. So b is going to be equal to 1 plus or minus 2i. Now 6 times 23 is going to be 138 all over 6. Now, again, we are okay with this answer, but the better answer, we need to simplify. We want there to be a common denominator. The 1 has a denominator of 1, so we want it to be 6. So in order to do that, I have to multiply 1 with 6 here. Okay, so I'm going to erase those marks here. So what we're going to do is we're going to make it equal to 6 plus or minus 2i rad 138. All of it is over 6. And we could simplify. This 6, this 2, and this 6 has a common factor of 2, which is going to be 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, or just I cancels out. Rad 138 over 3. And those are your two answers. And let's see if I'm right here at the bottom. Yep, right down here at the bottom you could tell that those are your answers for numbers 1 and 2. Okay. Number 3. We're just going to work up to number 3 today. Number 3, first step, move all your constants to the opposite side. We're going to subtract 53 from both sides. When we do that, we have 7x squared minus 14x is equal to negative 57. Then we divide both sides by a, which is 7. So we have x squared minus 2x is equal to negative 57 over 7. Complete the square. We're going to add c to both sides, which is just a plus 1. And we factor the perfect square trinomial, so it's going to be x minus 1 squared is equal to, simplifying, negative 57 over 7 plus 1 is going to be negative 50 over 7. Take the square root of both sides. Square root cancels out with the square, leaving just x minus 1 is equal to the positive and negative square root of negative 50 over the square root of 7. Add 1 to both sides. It comes to that place where I have to move it up to the other side of the screen. So we're going to have x is equal to 1 plus or minus the square root of negative 50. Now, the square root of negative 50, I could factor out a 5, or I could simplify with 5. That negative sign becomes I, so it's 5i rad 2 over rad 7. We don't like a rad 7, so I multiply both the numerator and denominator by rad 7 to rationalize the denominator. So it's going to be equal to 1 plus or minus 5i rad 14 over 7. Now we could be done here, but we want to do one more step. We want to have the 1 have the same denominator as the 7, so we multiply that by 7, so it would be 7 plus or minus 5I rad 14 over 7. And that's the third answer. These are the solutions to this quadratic. So lots of steps here. Just take it a step at a time. The more you do it, the easier it gets. Okay, and you could see that we were going to do one more. If you want to try one more, you could see down here at the bottom. If you want to try number 4, your answers are right here for extra practice. And that concludes this lesson.